I'm live. Start recording. Alright. Alright, let's see. Okay. Wow, that's delayed. Alright. So, I'm gonna turn my ceiling fan off because it's making a really weird sound. Okay. So, what are we doing today? What are we doing? I'm gonna go ahead and put you on my second monitor. What are we doing? YouTube, get stream key. Thank you, Helium. So today we are programming the Nether Star's flight computer. Well, not the Nether Star, a drone. So, you know, let's actually open Minecraft. I think that'll make things easier to understand for you, stupid people. I'm Ricky. Don't worry about him. He's just really thirsty, okay? Just don't. He's thirsty, okay? Why am I so unpopular? How long do I have to do this before one person joins? It's just I'm in hell right now. Just red all over my face. This is a really powerful monitor. This monitor is bright as hell. Dude, I got this 200 Hz 1440p monitor in front of me. $100 refurbished from Acer on eBay. From the actual company. For $100. 200 Hz 1440p. Crazy deal. It's like the only thing that was... Ah, man. Alright, so we're gonna go to here. I'll turn desktop audio up a bit, but not that high. This stream's gonna get copyright claimed because I have the Song of Freedom. Song of Freedom and Captivity in the background. My hair gets in my face, goddamn it. I haven't showered in like 2 days, I'm disgusting. Okay, oh, there it is, okay. So, this is what we're programming today. This machine right here. This is the template for the drones. It's a very simple thing, it's already mapped out. All the thrusters are mapped and everything, so it's fundamentally simple. So let's take a look at what I got so far. So what we're looking at here is the... I'm going to zoom in because I know it could be hard to see. So this is the folder. We have build over here, and we have some other stuff used by TSTL. So, oh look, I'm lagging. My face is lagging. Okay, so I described this a lot in the recent video, but I'll describe it more. We are using, okay, I actually need to start from the beginning. The Nether Star, why can't I go in third person? My mouse keys don't work. I guess my mouse keys just don't work. Okay, so that's annoying. So this right here, this machine is the drone. It is going to be a navigation drone, meaning it's gonna have LiDAR sensors. I just haven't put them on there yet. And so the point of this is we're trying to go to the netherworld border. So we're gonna have a series of craft navigating and breaking through terrain, through the nether, 30 million blocks to the end. It's gonna be a crazy big old thing. And it's going to be happening, like I said, for like 200 hours. 30 million blocks for 200 hours. A series of different types of craft need to keep themselves in the air in a choreographic dance of stuff happening for 200 hours without fail. So I'm using like aerospace level guidelines designing these programs to make sure that they absolutely cannot fail. So that brings us to what we're doing today. You can see here we have all of the actual systems that the craft is going to have. This is a first level overview. It's not complete. So I'm going to quickly talk over them, and we're going to talk about what we're actually doing today. So at the very top, there is the flight management system. Flight management system is sort of like the main computer. It is what handles everything else. You can see it's sort of attached to everything. It's sort of isolated from the flight stack. It doesn't fit in at the communication stage. It interacts with every single part of the flight stack. Aviation, navigation, and communication. Systems that pertain to either of those three things are in the flight stack, and they must follow this guideline. Aviation is below navigation. Aviation doesn't know what navigation is doing. All it knows is what it's telling it, right? Navigation doesn't know how communication is doing its shit. All it cares is what communication is telling it. So it doesn't. So for example, the stability augmentation system, which is in aviation, doesn't care what the terrain and destruction avoidance system is doing. It doesn't, or how it's doing it, or what calculations it's doing. All it cares is the final product that it receives from it. Effectively, every single machine, every single what would you call it? Program? Systems. Yeah, every single system only cares what the system above it, or sorry, does not care what the system above it is doing. It treats it as if it's a black box. However, for example, the terrain and destruction avoidance system can read information from, for example, the reaction control system. The reaction control system could broadcast an alert such as this vector with this dot product. It's hard to explain, but effectively the craft can't turn at this angle or something. The terrain and destruction avoidance system can read that. The terrain mapping and area pathfinding system can read that. The terrain destruction system can read that. For example, the stability augmentation system had an error. What error could that be? Like there was a collision occurred. Like a broadcast and alert, hey guys, we just collided. The terrain and destruction avoidance system, or sorry, no, that'd actually be the responsibility of, would that, no, that'd be the responsibility of the SAS. SAS system is responsible for, would it be the destruction of TDAS or SAS? SAS doesn't care about navigation. TDAS does. TDAS tries to avoid it. So that would be the responsibility of the stability augmentation system if a collision occurred. Because it doesn't care about navigation, and its goal is to maintain stability of the craft. So it would be the only one able to directly read that information. Okay, so the stability augmentation system would broadcast an alert, for example, if we collided with something. The stability augmentation system would broadcast that to everything above it. The terrain and destruction avoidance system could read it all the way up to the cross-craft communication system, and obviously the flight management system and the crisis management system. We'll talk more about those. Those are able to read anything. They're not in the flight stack. They're sort of controlling the flight stack. That's, yes, but the stability, for example, if this SAS did broadcast an alert, the reaction control system, which sits below it, would not be able to read that. The RCS would have no idea that we just collided into something. It doesn't need to know that information, so it doesn't get that information. If the terrain destruction and avoidance system saw that, holy shit, we're about to go into a fire zone where a breaker is about to fire things, it would broadcast that to everything above it. Would that be right? Yes, it would broadcast that to everything above it. It will say, hey guys, holy shit, what are we doing? We almost just went into a fire zone. What's going on? Especially, the most important one in that case would be the cross-craft communication system to tell the laser drones, the breakers, to not fire because we're in a fire zone. But the stability augmentation system would have no idea that we were in a fire zone. All of it would know is that it just received this very large magnitude vector telling it to go this way right now. And its job is to do that safely. Okay. And when it comes to velocity, speed management, I'm not exactly sure. Okay, this system works well, but it gets really hard to classify responsibility at the boundaries. The biggest issue right now I'm having is determining what do TDAS and SAS do. What is their responsibility? Like, which one of them is responsible for avoiding a collision? That one is the TDAS because it navigates. It navigates away from a collision. But the SAS is responsible for stabilizing velocity. If the TDAS sends down a signal that says, hey, do this crazy velocity to get away from this imminent collision, how does the SAS handle that? I don't know. I guess we'll see. Okay, but now, no, we're not done yet. The crisis management system, that's what I'm talking about next. The crisis, so actually, let's just talk about what they're all for, because I started getting in a rant. Reaction control system manages each individual thruster. The reaction control system is responsible for imparting a torque on the craft and using each thruster to achieve a desired velocity and rotation. That system is not responsible for example, an issue that it does not pertain to an individual thruster fault. Like if we look at the errors, an individual thruster fault, like let's say this thruster fails and it gets into a rapid spin because the thruster failed. That is the responsibility of the reaction control system. If we got into a situation where the navigation computer was sending this crazy spin signal for some reason, that would be the responsibility of the stability augmentation system, because that stability augmentation system covers maintaining the velocity and orientation of the craft as a whole rather than individual thrusters. If we were about to enter a fire zone or about to collide or something, that would be the responsibility of the terrain and destruction avoidance system. The terrain and destruction avoidance system, its sole purpose is to avoid colliding into something and avoid going into a fire zone. Then directly above that, simple avoidance and navigation system. Responsibility of the simple avoidance and navigation system is to follow waypoints. If we were to repeatedly go to the same area where we know that we can't go through, like we just kept trying to go into a wall, it is the responsibility of the simple avoidance and navigation system to preemptively avoid a collision. The TDAS is mainly there for like when other systems fail. It is its job to preemptively not go into a fire zone, and it is its job to preemptively do basic pathfinding around an area. If it can't, it will broadcast a distress signal via the crosscraft communication system. Above that, we have the flight events sequencer. The flight events sequencer is designed for sequences like takeoff and landing, so like actual sequenced events. In parallel, we also have the terrain mapping and area pathfinding system. This is the most complex system. It uses LiDAR sensors and stuff to figure out where it is and to map its environment using probability vectors to try to get, or probably, I don't know. I think I just made probability vector up to find a way through the terrain. Terrain destruction system is for the breakers. That is the navigation and firing mechanism to destroy terrain if we have to. And then, of course, above that, we have the crosscraft communication system. And then at the very top, next to the FMS, we're talking about the FMS, the crisis management system. Crisis management system is sort of there for when stuff doesn't go right. For example, if the simple avoidance and navigation system physically cannot find a path through the area that it's in, it will tell the crisis management system of the failure, and then it is the job of the crisis management system to figure out what to do. In that case, the crisis management system would likely broadcast a distress signal via crosscraft communication system. It exists as a bridge because not all systems can interact with each other. For example, the stability augmentation system gets into, it detects like that we just collided into something. It will send that as a distress signal to the crisis management system. The crisis management system would then figure out, it would probably inform the simple avoidance and navigation system. It will figure out who is in charge of navigation, and it will tell it, what the hell are you doing? We just collided into something. Get your shit together. So that is the basics of it. So yeah, that's the basics of it. That's the basics of it, okay? This is going to take so long. So today, finally, after recording for 14 minutes, I'm finally talking about what we're actually doing right now. Is we are programming the stability augmentation system. The RCS system has already been started. It doesn't have perfect error handling. There's a lot of stuff that needs to be worked on that we'll probably work on too. But it's at a point where I want to be able to test the system, and the RCS system sort of relies on the SAS system to maintain stability. Like the RCS, like if I were to activate this, like I'll actually show you. If I were to activate this, like it's able to sort of do its job. It's being told right now to not worry about its rotation, or hold on, make it smaller. It's being told right now. What the hell? Shit. Okay. It's being told right now to not worry about its orientation and to try to go to this position, but it's not doing a very good job because the thrusters are overfiring, the velocity vector isn't doing the best job, and that's because, and that stuff isn't individual thruster stuff. That is a whole ass velocity and orientation problem, which again is the responsibility of the stability augmentation system, which is what we're doing today. So, in the code, you're going to see references to a system called SARCAS, or Stability Augmentation and Redundant Collision Avoidance System. That was a prototype where SAS and TDAS were combined into one. I separated them just recently because I realized that it was both aviating and navigating. It would have to contact the crosscraft communication system, which sat 2 tiers above it. It couldn't do that. So I split that into the SAS and TDAS system. Alright, let's go ahead and start programming. First, we need to get a new theme, though. This is 90% of me in VS Code, is just getting a new theme instead of actually programming. I have so many. I really like the Vera theme. Hold on, where is it? Oh, Jesus! Dude, you can actually see that, like a spotlight. Jesus Christ. That's a lot better, okay. Which one do we want to use? I literally change this like twice a day, if not more. And dark isn't bad. I don't like the purple, like that pinkish purple, like that you see on update. That looks disgusting. I don't know why people like that. It looks disgusting. Or that abundance of red. God, stop doing that. Okay, let's look at the Vera theme. Does this cost money? Right, how much does this cost? This is crazy. How much does the Vera theme cost for VS Code? Free trial. You cannot be serious. Okay, it's a trial. Okay, tell me that this. I want to be like, I really hope this is a one-time payment thing and not a subscription for a theme, because that would be actually crazy if I had to pay a subscription for a Visual Studio Code theme. That would be ridiculous. $10 color schemes. I'm about to buy this. I have enough money. I'm about to buy this. I'm about to buy. Hold on. I'm gonna shut off the screen capture. I'm actually about to buy this because I think I really like this thing. It costs money to use it in JetBrains too. Oh, I don't use JetBrains, so that's good. I've been thinking about it. What does it mean by one-time activation? Is it like, is it tied to my Microsoft account? Or do I get it on this computer only, and then when I factory reset it's gone? That, okay, that would be crazy. I'm gonna have to pay a fee for this shit because, hold on, where's my debit card? This is crazy. I'm gonna have to pay a fee. I'm gonna have to pay. Additionally, you must be able to access our domains by pursuing this requirement. You acknowledge it. Network connection is essential for the installation. All the plugin can work in our VS Code-based servers. We don't officially support those. Support now ensure your personal activation count. As upgrading the license to add more activations won't be possible. Is Vera theme tied to Microsoft account? No. Extension. The proprietary license. So if I install. Okay, so I'm just making sure that when I buy this theme, it's not going to be like I get it one time, and then I'm fucked for the rest of my life. Like I factory reset. I get paid like every 6 months. I just factory reset and it's gone for. I bet it's been like $12 after the international fees. This is okay. No regrets. Dude, I was gonna spend this. I was saving this money because I submitted an open records request because we had to call 911 recently. I won't get into it for privacy reasons, but it was really interesting. The fucking county wants me to pay $50 for it. That is crazy. $50 for an open records request. They said it was the search fee after the first 15 minutes. I gave them I think I literally gave them the case number. I gave them the exact time, date, phone number, everything of the call. I gave them absolutely every single piece of information. They told me within 15 minutes of me sending that message, they got back to me and said that they found it and that it would cost me $50 because it took more than 15 minutes, even though there literally wasn't 15 minutes. I should sue the county, but that would cost me a lot more. Also, I don't have money for a lawyer. I just realized I was saying the numbers of the card out loud. I probably should not have done that. Okay, it's gonna cost me 48 cents in taxes. It says there's a discount, Vera theme discount code. Does this code work? Whatever. Pay now. Buy it. I don't care about the discount code. Just buy it, okay? Take all my money. Take it all, you know? Just take it all. Let's just be like a huge scam and like all my money's gone. Just some random ass website. We need to verify your identity to complete the purchase. God damn it, dude. Yes. Send me a text message. It's better. This is my phone. This care. Okay. That's me. Identity verified. Oh, you may close this window. Okay, go ahead. Give me my theme. Payment successful. Hell yeah. Your purchase for $8.48 was complete. God damn it, dude. I could have bought something important. Give me my license key. I'm not showing you guys this shit. Access my purchase. This is the most important thing I've ever done. I actually don't hate the Vera theme. It actually looks really good. Okay, install. Okay, first let me activate it. Hold on, Vera How do I activate my license? I'll just do that one for now. How do I activate it? Is there no activation? I remember there being an activation button, it's not there. Maybe it, I don't know, maybe it just used my IP address or something, because it's not telling me to update it. So, I mean, okay. Change folder, change file color. Okay, can I use the themes that come with it? I mean, I guess they did put a lot of work into making the theme, so I can't be too mad. I guess I'm just glad it wasn't a subscription. Because if it was a subscription, that would have been crazy. Like, genuinely, no, that would have been crazy. There's a lot of Vera. I'm trying to figure out the right one, okay? I don't want to show anything in case one of y'all can accidentally get my code. Ooh, I like that one. I'm trying to justify this purchase. I like carbon. Carbon, like the default carbon one, that looks pretty good. That looks pretty good. Change icon theme. Icon. Your theme. I just don't know what the icons look like. Preferences, file icon theme. Preferences, file icon theme. Okay. Oh, okay. File icons carbon. Oh, they're all the same. Okay, well this is the theme I'm using for the rest of my life because I spent $8 on it, so make sure I'm not showing my purchase stuff. Okay, here it comes. This is my theme now, forever and ever. I can't change it. I spent money on it, so okay. My cup of coffee is nearly empty, and I got fuck. Okay. Let's move you off the screen. Let's start programming, guys. Let's get programming. Let's get to the programming time. Okay, programming. It's time to program. Okay. So let's take a look at the reaction control system for a bit and see. I remember there being an issue. So again, this is all programmed with TypeScript and transcribed to Lua because the computer craft computers need Lua. So I remember there was an issue. Like thruster lost. It logs RCS thruster failed. We go into a degraded state. But there's this emergency spin condition. This is activated. Okay, so this would be activated by the okay, so sorry. Failure management system. This was the old name for the crisis management system. I changed the name because is it crisis or crisis? Which one? Okay, is that how you spell, how do you spell crisis? A crisis. Okay, yes, it is crisis. Okay. Worst possible failure mode. Yeah, shut up. So we're gonna rename the failure management system to the crisis management system. Export crisis management system. Okay. Go to the main flight computer, which is the flight management system. Import crisis management system. Crisis management system. Public CMS equals new crisis management system. Reaction control system, you have some errors. This dot CMS equals FMS dot CMS. CMS, what is that I heard you say just now? From Crisis Management System. You are the Crisis Management System. Okay. Oh, I just like stabbed myself with my... Let me turn up my brightness on my phone. For some reason, it's like so dark. I cannot see shit. There, I can see myself now. Okay. I've been recording for a long time. I can't check because my phone is like over the time. But I haven't write a single line of code. So let's get started. Let's actually start programming, guys. Let's do the programming. Oh, one more thing. I actually have a GitHub repository for the project. It always takes me to SprayOSD. I have not used SprayOSD in so long. Every time I type it in though. Another star. This is the project, and here we have all the program requirements. So I'm going to be we're going to be referring to these program to TypeScript, compiled to Lua. No usage of the as operator for every logical branch. There must be a contingency for the opposite or no path. Must explicitly type every single function variable, no exceptions. No heterogeneous arrays or tables, so no tables that have multiple types in them or as the index. No circumstances should the any type be used unless referring to external libraries where the type cannot be known. In such a case, it is absolutely imperative to make a container for the object. Its contents reduce the use of external libraries. Avoid creating short-lived objects inside loops. Define outside the loop and assign inside. No recursion. Nesting limited to 2 except for one-liners like errors or returns. The one time you can declare an object with more than one possible type is null. For example, const magnitude number null equal to vector magnitude. The variable can only be used once the null is verified to be logically impossible. It can help only conceptually and cannot write any code. By that I mean it can write code in like the prompt. Like if you're asking how do you do this in TypeScript and it says, oh, to do that you do this, and it shows you. You don't copy and paste that code. Make sure you understand it conceptually and then do it, right? Like for example, it helped me with the interface yesterday. I didn't know how to use the interface. I'm new to TypeScript, right? I know C-based languages, so it was actually not that difficult. I didn't know it. Fuck. I didn't know what an interface was, and it showed me, hey, you can use an interface for that. And then I looked up what an interface was, and there we go. So conceptually. Each craft has the main requirements. So these are the priority requirements. This is basically if you've ever done flight. Like I'm actually really into aviation and stuff, so this is why I chose this, because this is one of my goals to be a pilot in real life. So I knew sort of already what the priority list was, which is aviate, navigate, communicate. Each craft has the main requirement of maintaining its own orientation and stability. This is aviation. It must not spin out of control crash. This is the priority. When that is fulfilled, the craft's next directive of navigation, where they're following waypoints or using an advanced pathfinding system. The third priority is communication, and the last priority is anything else, which for a flight computer should be usually nothing. A computer which needs to significantly do something else should be both physically, mentally, and pragmatically separated from this stack. For example, the main orchestrator aboard the Nether star and the display computer displaying information are separate from the flight computer, only communicating via the cross-craft communication system. We're doing this because we want to reduce the amount of failure modes to the minimum possible for the flight computer. Or it can be more lenient on the other computers, but for the flight computer, it cannot fail. That is like, it cannot fail. It cannot fail. We need as many contingencies as we possibly can to stop it. Preemptive procedures and contingencies. If you don't know, preemptive means like a preemptive procedure, preemptive protocol. Portal 2. Is something that happens, is something that you do before a bad situation to stop it. Like a preemptive protocol would be turning to the left to avoid a collision. A contingency is what you do after the fact, like colliding into something, immediately restabilizing yourself. That would be a contingency after it's already happened. Or more specific, a contingency is a plan of what to do after. Okay. Okay. Stability augmentation system. We need to set that properly, because that does not exist. Okay, let's go ahead and make it. New file. Stability augmentation system. That's how you spell augmentation, right? Watch it be wrong. Yes, it is. Not. Actually, it's not wrong. Okay. What's right? What is this? What is the stability augmentation system? You ask. The stability augmentation system. SAS is responsible for stabilizing the craft in situations in ways that don't require individual thruster action. It sits in the aviation stack above the reaction control system and feeds commands into it. For example, a failure of a thruster causing a rapid spin is not the responsibility of the SAS, as it requires individual thruster action. A rapid spin caused by a navigation computer sending faulty data is the responsibility of the SAS, as it can be what? What's the word? Like repaired? As it can be remedied. Remedied. This is not used for remedied. I'm like the worst speller ever. Oh, you know, I actually was not that... I wasn't that far off. Without individual thruster action. Okay, so this is the SAS system. Stability augmentation system. Let's start programming. Okay, class stability augmentation system. Constructor. So we need a few parameters. Private FMS equals is going to be type flight management system. Private config is going to be type configuration. That was disgusting, I'm sorry. So we need to pass through FMS. This.fms equals FMS. This.config equals FMS.config. Okay. What else do we need? Stability augmentation system. There's PID loops. So we need to define those. So private translation loop equals it's gonna be type PID controller vector, and private rotation loop is another type PID controller vector. Is it? Go to update rotation. It takes in the sarcasm, or sorry, there needs to be SAS. I'll update that in a minute. It just multiplies it. Okay, for now, let's just do component multiply. Right. So I'll do SAS raw multiplier. Or do we not even feed it in? Right? It could be the case that we don't need to feed it in. We feed it in the error quaternion. Do we feed it in a target quaternion or an error quaternion? I think we do error quaternion, right? That makes sense because for the separation. Yeah, okay, so then it doesn't even need to worry about sarcasm at all. So we'll just call this error quaternion. Instead of calculating error, world error, we just don't, because we already have it. It's right here. And it should be in world space. Then it is the responsibility of the stability augmentation system to do that. Then we don't need to multiply you. We just return adjusted. Sarcasm rotation multiplier, we don't need you anymore. Desired current quaternion equals ship bridge, get quaternion, desired velocity, current quaternion, your error quaternion. Update, thruster update, global rotation dot, oh no. The hell was that? Make that sound. Okay, I think that's good. Right, flight management system. I had this testing thing where I just like was just setting it manually, but we don't need that anymore. Okay, we can initialize the loops from the config. So if we take a look at the config. If we go ahead and we look at the actual entry drone.ts, this is the entry point for the drone type. Drone type, it literally the entry point is it just initializes the FMS with data specific to that computer. It's craft. It's effectively a config file. We can see here we have the sarcasm rotation loop, which has all the information. I need to rename you to SAS rotation loop, and we need to go to the configuration interface and rename you to SAS rotation loop, and we need another one, SCS translation loop. And we'll just keep it translation loop. These are all going to be, the minimum is going to be -1, the max is going to be 1. Maybe we could remove that because that can't be changed, but for now we'll keep that just to keep things simpler for what we have. Okay. This translation loop equals new PID controller vector. We need to give it the PID, the minimum and max. So we're going to do this is rotation loop, right? We're doing translation loops. That's going to be this.config. Minimum, no, that's going to be SCS translation loop .p. That's a bit long, but ID PID min max. Okay. And we'll do the same for the rotation loop. Alright, now this is a system. Every system in the stack must have a function called the power on self test. Power on self test is effectively a test that verifies that everything that this system needs to do, it is capable of doing. It is able to do things. Its responsibilities, it is verified to the first level of knowledge that it can, that it is functional. Okay, this is like, if a thruster doesn't exist, for example, the RCS power on self-test will catch that and stop it. And during testing, interestingly, that actually happened. The RCS system failed the power on self-test. So, these are actually super helpful. I really like having a power on self-test. And so I like doing a try catch block. We have to be careful here because right now we are at the max level of recursion. We're at 1 and 2. If we were to write, for example, an if statement here, the if statement would have to either be one line, like a one-liner. And by recursion, I'm sorry, I should specify. By recursion, I don't include classes. Classes aren't included in the recursion. I only mean like this. So for example, public power on self-test, that would be at level 0. Try would be at level, the try block would be at level 1, and whatever I type here would be at level 2. And it has to be like a simple, real quick thing, like a return or an error. If I need to do something complex that is more than one line, I need to put that on another function. So the stability augmentation system's responsibility is maintaining the orientation of the craft, right? So what does it need to be able to do? It needs to be able to get the orientation of the craft. It needs to be able to get the current velocity of the craft. It needs to be able to communicate to the reaction control system. Those are its responsibilities. If it cannot do those things, then it cannot activate, right? So the power on cell test for the SES is pretty simple because it doesn't have any actual power on hardware. It's entirely a software-based thing. It takes in the same thing it outputs, it just manipulates it. It takes in a velocity, and it takes in an arrow quaternion, and then it outputs a velocity, and it outputs an arrow quaternion. All it does is manipulate it for stability. So, oh, sorry. Yeah, I guess. Should it take an arrow quaternion or a target quaternion? I think I'll do target quaternion, to be honest, because that would be a lot more stable to maintain. And it's not like a lot. Yeah, okay. So the RC, yeah, and that would be easier with the rotation up. So it's going to take in a target quaternion, not an arrow quaternion, and then it converts that into an arrow quaternion for the RCS system. But no, quaternion is a method of representing three-dimensional rotation by using a four-dimensional something. I don't fucking know, dude. I use ChatGPT for all the math. Quaternions go right over my head. I watched this like hour-long video. I'm not talking about this. Okay, I'm talking about it again. I watched an hour-long video on quaternions by this one lady, and it was super good, and it really helped me. But that was like 4 months ago, and I've completely forgotten. I don't remember. Anyways, I need a program. I need to actually write code. Okay, we did the power on cell. No, we didn't do the power on. I don't have any. They're both empty. God. Are we able to get the quaternion? This is going to return. Get the rotation. Local. Const. Quaternion. Current current quad would probably be more descriptive. Quaternion equals shipbridge dot get quaternion. Current. Are we able to get the necessary information? Current angular velocity, we also need this, is a vector 3, equals shipbridge dot get angular velocity, const current velocity equals vector 3, shipbridge dot get velocity. There we go. If current quat and current angular velocity and current velocity. This is redundant. I'll make false and nil evaluate to false and lua. Everything else is considered true. Explicitly compare the value. Equals defined. So if any of them return undefined, which they literally should be impossible, they should error first. But this is just like, I just want to be sure. Then we have to max level recursion, so we need to do something that's a one-liner. We could say, let's just do a quick little helper function here. lst.log post failed one or more systems could not commit. One or more ship bridge systems failed. There we go. Just to log in or return. That's fine. So if we are able to get all those pieces of information, we need to now test the translation loop. Does it exist? So we need to run it for a tick. So the translation, this translation loop dot run, and we'll just do new vector 3. New vector 3 current velocity. Current velocity. We'll do const trans result. Const rotation result. Is this our rotation loop? Which, yes, the rotation loop does output a vector non for turning on. That's going to be a rotation current angular velocity. If trans result or rotation result would be equal undefined. Which when it doesn't really matter what we put here. When this gets translated into Lua, undefined means nil. So we could put null nil here. It doesn't really matter. It all means the same. Which is actually something I like. Someone transpiled something. Then we need to lsd.log. LSD stands for Lua standard, by the way. SAS post failed. One or more PID loops failed. I think it might be a better idea to put these in a try-catch block, because let's be so for real. If they fail, it's going to be here, and then like if they fail, because this returns a quaternion. It will return a quaternion, right? It must return a quaternion. It is impossible for that to be undefined. Otherwise, if it did give an undefined answer, it would return an error right here. This would error out. And then that would just go to this catch, which we don't want. We want to put the try-catch block in each individual one. So I say, yeah, let's do that. So let's just let current quaternion current angular velocity is going to equal vector 3 velocity, because we do actually need this for the next parts. So let's set you to current quat. Did we throw an error here? That would be ridiculous. No, we need to return false, and then we need to return. So this will say that when we return false, the FMS will say post failed. So the system won't even start. lstd.log SAS post failed. One or more ship bridge systems. Bridge functions returned. What's the technical term for gibberish? I forget. They say it's what the lawyers say. The law term for gibberish. Jargon. Yes. In the legal words, the highly formal term for gibberish. The actual Google is saying gobbledygook. Gobbledygook is an actual legal term. Well, okay, I'm gonna use jargon because that's what I was thinking of. Okay, I'm just gonna say jargon. If we get this far, then we'll return to it. How do you go to the bathroom? Okay. I think what you better actually here to say returns undefined. Or we'll just say null. I know, let's actually keep jargon. Returned, one or more separated functions. Returned, undefined, one or more continuous returned. Jargon. I like jargon. Okay. We can also log the specific error, like what actually happened. Specific error, and we'll just do dot or plus error. Now we need one more thing. To actually have this system run, the RCS needs to successfully perform its power on self-test. So this needs to occur after that, and to ensure that, we need to check, is the RCS power on self-test successful, right? So if we go to the reaction control system and go to its power on self-test, this state equals RCS state.active, right? So we do if we need to define RCS system. So we could just do private RCS equals reaction control system, and then we can get the constructor and say this dot RCS equals FMS dot RCS. And we could do if RCS dot state this dot RCS dot hold on. Also we need to do this stability RCS. Is state not a public variable? Well, it shouldn't be, no. That makes sense if it's not. Yes, okay. We need to do a get. So we'll do public get state. It's going to return RCS state. And we just want to return this dot state. If this to RCS dot get state doesn't equal RCS state dot active, return false. lstd.log post failed. RCS is not active. Did it post? Okay, and that is the power on self test. So the goal, like I said, of the power on self test is to catch any error before it's too late. We don't need to keep those results. Okay. Now, we need to do the thing, you know, that thing that we do? Okay, let's do it. I don't know what the hell that was. Public update. This is going to be called by whatever program wants to call it, which is going to be the flight management system. Navigation system wants to call it? No, it won't. It goes through the flight management system. Every system goes through the flight management system. For example, this system is not allowed to directly call the reaction control system. It sends a request to the FMS to call the RCS. Is that a good idea? Yes. Because that means that no other system can control it forcibly. I think. Okay. We track, okay, system initialization. It tells it to call this system's function, and then it checks how many systems in the tick are trying to call it. And if it's more than one, we fail. No, we don't fail. If it's more than one system trying to call it, what do we do? What do you think we should do? No, that sounds too complex. We don't need complexity, we need simplicity. If we do rcs.update, that would make it simple. But what if another system was to call it? No other system is allowed to call it. Every system must go through the SAS. Okay, so we'll just call it then. I feel like I'm overcomplicating things, but like I said, this thing has to not fail for 200 hours. I'm trying to think of every single possible. I'm definitively programming to the point that I wrote the post system. My legs are here now. They've joined us. Okay, so this.rcs.update. We need to give it a desired velocity and an error quaternion. So we need to pass two pieces of information into here. We need to do a desired velocity that is the same, and this is going to be a vector 3. And the error quaternion is not going to be, that's going to be the desired quaternion. It's going to be a quaternion. The reason why we're doing this is because if something wants to change the rotation, all it does is change the quaternion to what it wants. Like, it can just continuously spin the quaternion. But sometimes things might want positions. For example, if something wants to constantly spin 5 degrees to the left, it would change it 5 degrees to the left every second and feed that into the SAS system to stably maintain that. If it were to just feed an error vector in, it would then be the responsibility of the systems above to aviate the craft, which it is not. Velocity, on the other hand, is not the same. Velocity... Not fucking no, dude. Shut up. Okay. So we need to do... Every tick, we need to do if... We need to make sure... We need to set the state, okay? Its state... can we just use the RCS state? The offline, active, degraded, emergency, and failed. Yeah, I think this is just a system state at this point. Because so many things need that. Okay, so we need to define our own state. Private state is a boolean. We'll set this. Dude, how did I write that? Okay, you know what? It's a system state. Fuck, how did I write that? System state dot offline. If we pass the post, system state dot online, or sorry, dot active. Update if this dot state equals system state dot failed. That's not good. Don't do anything. That is a return. That literally means we do nothing. The system has failed. It has completely failed. This only happens whenever the system is shut down or whenever it suffers a catastrophic failure. In the SAS, pretty fortunately, the SAS doesn't really have that many points of failure. So I think if we fail, we return, but we also just pass the data through. Like, we might as well do that because it is technically possible the RCS system is still running. In that case, we need to send that data through. Like, just in case the RCS can somehow make sense of it. Desired, it expects an error quaternion. We're sending a desired quaternion. So we literally physically cannot send rotation data to the RCS without processing it. So we could just do new quaternion 1 0 0 0. This is the, as far as I understand, this will just make it not do shit. It'll just not do anything with its rotation. If this dot state okay, so if it's not if it's not failed, then it could be in any of these states. It could be in, hold on, I'm gonna move this outside of the RCS block into its own system state. TS, I'll put this in here. Why are you doing that? Okay, so if you look at the, where are you? The system state. You can see that offline, active, degraded, emergency, and failed. So we need to make sure it's not offline. That is very important, because if we do that, that means we tried to run it before the post. Not failed. If it's failed, we don't error, because that means the system failed. Like, it is intentionally offline, right? But if it's offline, that means it just hasn't posted yet. So if this dot state equals system state dot failed, and we're trying to update it, we need to throw a new failure. I don't know why I typed new like that. Failure SAS attempt to update SAS attempt to update when pre-post, and we need to give it a failure mode, which is failure mode dot, hold on, I think it's not RCS post failure, it would be, what would it be? So let's go to the failure state. Okay, RCS post failure, RCS update before post. If this dot state, oh, I need to return it. Okay, if this, oh, what do I need to do? It's starting to fail. This dot state equals system state dot failed, or sorry, this needs to be offline, not failed. But we will log it because that is still useful information. And we should probably inform the flight computer of that we were updated while we failed. But I don't think that's really something we need to do right now. I don't think that's a current priority. So log SAS attempt to update while failed, passing through translation data to RCS. Okay, now if we made it here, we're online. Okay, we are working, but we need to verify, is the RCS working? So we need to check, is it not offline and is it not failed, right? And we need to change you. Okay, so we need to do if RCS dot. We need to even check this before we failed. If this dot this, oh, hold on, let me change you to include this as the stability augmentation system. If this dot RCS dot get state doesn't equals system state dot failed, then also we want to log that there was an attempt to call it when it failed. SAS attempt to update while RCS is failed. I just want to return. If this state equals failed, attempt to update while failed, passing through translation data. We could just do this dot RCS dot update desired velocity, and we do new quaternion 1000. Okay, so if we've made it here, if code reaches here, all systems are running and operational. All required systems are running and operational. Okay, so if the code path reaches here, we're effectively good to continue, right? We've made it. Okay. Next, what's next? This is where the SAS system has to actually do what the SAS system does. What does the SAS system do? PID loops mainly. Going to my place of knowledge. What the fuck is this loser doing here? Fucking loser. When did this guy get here? Literally, when did he come here? Was that just now? Oh, it's right now. He's literally here right now. What is this asshole doing here right now? 322111. What does that mean? I'm actually speaking to this asshole right now. What are you doing here? Why are you alive? Hello, I am actively answering you. You fucking idiot. Hello. This absolute asshole. I know stream delay is not that bad. I can literally see myself. I can actually see myself. Stream delay is not that bad. Hello, I'm an asshole. Dude, I'm gonna kill you. Okay, you know. Literally see my. Okay, you're full of shit. You're full of shit. You're full of shit. Good, finally. Me when I'm watching 20 minutes behind. Okay. I think. What? Translating. I'm a bola of shit. When I hover, it's like a translation. What the hell is that? What is going on here? When I hover over it, like translate. What is this? It's like translated. Okay, you know what? I don't even care. Billy Wonka's here. Okay. Ben, what is the SCS supposed to do? I keep forgetting. Or I not forget. I just, it's like, I know what it's supposed to do. I don't know. Stop staring at me, loser. You're looking at your phone, staring at me right now. Dumbass. Yeah, get wrecked, loser. Shitting right now. Okay, was that worth it? Did you have to say that? Was that necessary? I don't really care, you know, that you're shitting. SCPR monster. What? Okay, that's cool. I don't know what that has to do with anything. It's SAS. It shares one letter. Literally one letter is shared. Okay. Private. Stabilize. That's how you spell stabilize. Dude, this stream is mostly just me not knowing how to spell shit. Stabilize. Stabilize. Private stabilize. What are we stabilizing, I hear you ask? Well, we're stabilizing the desired velocity, right? Devoured. Yes. Desired velocity is going to be stabilized. And we're going to be returning a vector 3. Private. I know, right? Yes, I know, right. Stabilize velocity. Private stabilize orientation. We're going to take in the target quaternion, and we're going to output the error quaternion. So what adjustments the RCS system has to do to its thrusters. Okay. So we need to actually run this. So we need to say const stabilized velocity equals stabilize velocity, desired velocity. This will, like, want to play Ocarina of Time with me. Ocarina of Time? Are you joking? Is that a joke? I'm sorry, I don't want to play that shitty ass game for losers. It is the worst game ever made. I can't believe you'd even ask me that. What is it? You know, matter of fact, what is wrong with you? I hate you. Do you want to play Ocarina of Time? Who do you think you are? Who do you think you are? I actually can't believe you asked me that. Number 1 on Metacritic. Well, Metacritic is wrong. Update rotation, and this should be a private. That should be private. Velocity stabilized air required. Catch. We need to. So if the RCS fails, that's a pretty big deal. The RCS, we should. How do we handle that? If the RCS isn't responding, then we need to check if it's failed. If it has not failed, then okay, so this isn't really our domain. A system failure isn't the domain of the SAS. System failure is the responsibility of the crisis management system. So we need to tell the crisis management system that there was a system failure. So I'll do public system not responded, system not operating error, right? And we'll see. We'll get a system export enum system name, and we'll do reaction control system stability augmentation system. We'll do just those two for now. So we'll do this will be the crisis management system. Caller is going to be system, and called equals system name. So we can do if, so this is effectively, the caller is the system that is reporting that the other system that it's trying to call isn't working. So there could be different things. For example, by the way, I had a dream where the towel was clogged with towels. I had a quote, I had a dream where the towel was clogged with towels. And I dropped my keys into it on accident. What does it mean for a towel to be clogged? I'm slightly not understanding that. And for now, this will just be a stub. And it's going to return void. It's not going to do anything. Toilet. Okay. Sorry, why are you not working? Expected stabilized velocity to have annotate. Oh yeah, yeah. You are a vector 3. Okay, because we were there. Remember when the mushroom was growing under my bathroom? How could I forget that? Like, how could I possibly ever forget that? And we'll do system name dot stability augmentation system, system name dot reaction control system. So we're following this whenever the, like, if we try to tell the RCS system, hey, do this with your thrusters and stuff, okay, and it doesn't work, we are going to send a system not operating error that basically says, hey, crisis management computer, I got a crisis for you, it's not answering me, what do I do? And so this will tell the SAS to do something, but it's not really the responsibility of the crisis management system to handle this. That's the response, or it's not the responsibility of the SCS to handle what to do when RCS isn't responding. That's the responsibility of the crisis management system. We'll output it. SAS, RCS, not RCS, call failed, and we'll do the error. Okay, so let's do stabilized velocity. So to do this, we need to get our current velocity. So current velocity with shipbridge.get velocity. This is our, and this is going to be type vector3. Right? So this is our velocity, and we need to figure out how do we stabilize our velocity so that we reach our desired velocity with a PID loop. PID assignment doesn't change throughout flight, so we don't need to constantly check that the PID loop is still active. We do that one time in the power on self-test. We need to now set it. So question, do we handle velocity stabilizing in terms, oh fuck, there we go, okay. Do we handle, I'm down here now with the very bottom, Matthew's in the back. Do we handle emergency situations of velocity in here? What I mean is, if the velocity is above the maximum forward speed, we need to have some sort of system to handle that. If the velocity is too high, we need to bring it down. Done? What do you mean done? You're done shitting already? That was not... Okay, whatever. Alright. So we can do const PID result equals this dot translation loop dot run, and we need to give it the error. So the error is the const velocity error Matthew, that's some shit Matthew would do, showering and shitting at the same time, quick as hell. It's disgusting. It's going to be target, take away current. So if we want to go to 3, and we take away 2, okay, yeah. Okay, so we do target, take away current, so we're going to do the desired velocity dot subtract the current velocity. And so that's going to give us the error in our velocity. We're then going to feed that error into the PID loop. PID loop is going to do its magic stuff, and then it's going to give us a result of stuff, you know. And my webcam disappeared, because of course it did. Then it's back. Okay. No, it's frozen. No, it's should end back. And okay, come on, bro. Come on, connect. Fat ass. That's not funny. That's not funny. That's a serious medical condition, and I'm so sorry for you. Why is it green? Come on. Stop being green. Oh, fuck. That's bright as hell. Here it is. Oh, hello, handsome. Oh, I like to scut. Fuck. Okay. Okay. Okay, I don't know what the hell that was. We need to clamp the desired lot. So we need to. God, that is so bright. Okay. Okay, we need to go to the config file and set the maximum forward speed. This is literally the fastest we can go. That's going to be a number. So, if velocity error if current velocity dot magnitude, or we don't really care about that. We only care about desired velocity. If desired velocity dot magnitude, I fella bad for felines like you. Thank you, I guess. This dot, sorry, like I'm not supposed to care. Config dot maximum forward speed. So if we're going too fast, we need to. What do we do if we're going too fast? Well, the very first thing is our responsibility to maintain stability. So we literally we refuse to accelerate any faster, right? So we cannot accelerate faster. We need to, the closer it gets to the desired velocity, the slower we need to go, right? So we need to put it on, we need to have like a curve so that when it gets to a certain point, it starts rapidly not allowing speed to the point that it gets to, like, it literally won't let you go any faster. But we want to limit that pretty much almost exclusively to the translation axis. We do not want to take away velocity or from translation to the translation axis, the X and Z axes. We don't want to do that on the Y axis because we don't want the craft to fall out of the sky. So we need a way of slowing down the X and Z logarithmically as we approach the maximum forward speed, whilst simultaneously broadcasting an alert to the navigation computer above it that we are going so fast. We're going too fast, and the SAS system is having to forcibly slow us down. Actually, you know what? I don't think so. I actually don't think so. It is not the responsibility of the SAS system to do that because that is a navigation, right? We're not trying to do that. What we're trying to do is we're trying to this SAS system to maintain stability. Oh my god, this fucking surgery. It's supposed to forcefully. It's like the instinct. It's supposed to like forcefully stop it. So the SAS system isn't so much like a slow stop on the accelerator. It's more so like a jolt in the opposite direction to stop it. So we need to create an inverted vector that points in the opposite direction. So we can say, but we're 2 layers deep. So we need to do we need to give it a slowdown, a deceleration vector. So we need to do const or private get deceleration vector or get rapid deceleration vector is going to be type vector 3, and this is going to take the current one into account, and it is also going to broadcast an alert via the board, the bulletin board sort of thing. I haven't made it yet, but it's a way that Terry said, "Hello." Dude, I bet I should shit myself. I guess I never existed anyway. Yeah. That felt good. Sorry. Sorry for existing. This would classify under the an emergency protocol. Sorry for existing, I said. I heard you say it. So, would it be worth it to tell the crisis management system of the overspeed condition? Do we tell the SAS system you're overspeeding? Or to the okay, I think it's worth it because the upward navigation computer has it in its program, do not overspeed, right? You have the speed requirement, do not exceed it. If we overexceed it anyway, that could indicate the SAS, or sorry, that could indicate the navigation computer has failed, right? So I think it's worth notifying the crisis management system that we had an overspeed condition when explicitly we're not supposed to have that. It is the responsibility of the navigation computer to not put us in an overspeed condition. And we want to check current velocity here. Love being ignored for no reason. You know what I think? I think we don't do this here. Because this is inside the stabilized velocity check. I think, and I love how I keep getting lower in the webcam. I think we do the overspeed check before we actually administer the desired velocity. Because right now it's kind of getting caught up in a confused place in the code. So I think we don't do this. It is worth it doing a sanity check on the desired velocity, though, to make sure it's not. But no, yeah, see, all of those sanity checks aren't handled by this system. The goal of this system is just to stabilize it with a PID loop. The sanity checks and the velocity are handled by a separate system. Not a separate system, sorry, a separate function in the SAS system. That was... Wow, that smells disgusting. Why's my chair so goddamn loud? Okay, so the input vector is verified. Its sanity has been checked, right? It is sanity verified. That means that this vector is the input vector, desired velocity. It's fine. It's good. We've already verified before, and we're good. This is a good vector, right? Oh, God. What is wrong with me? Okay. God. So the PID result is the result of the loop. I think super simple. We just return desired velocity. Or sorry, return PID results. The PID loop does a thing, and it returns it. Ah, but there's a problem. We need to verify that the PID loop, the PID result, yes, I do hate you. We need to verify PID result is good. How do we need to stop shitting yourself? Anyways, we need to verify that the PID result is actually good. We need to sanity check the PID result. Because what if there's a failure where we're constantly overspeeding,
right? But the issue isn't the navigation system, it's us. The PID loop is giving us wrong information and causing us to potentially, if we have it set up wrong, get us in a positive feedback loop. That could be catastrophically bad. If we get in a positive feedback loop, we're ultra fucked. So I think it's worth it to check the PID loop itself is keeping us stable, right? And that it's not fighting us, because if it is fighting us, if the PID loop is fighting us, then we need to indicate an emergency with the crisis management computer, basically saying like, hey, the entire SAS system cannot be trusted anymore, which would be catastrophic if it couldn't be trusted, because if it couldn't be trusted, then it couldn't even maintain position. So I think at that point, are you doing one for the end as well, or maybe if I do one for the end, it'll be really simple because there's no real terrain in the end I have to contend with. I'm thinking about the end. If I do the end, it's going to be something different than just the world border. It would be something more meaningful, because going to the world border would just be so easy in the end. It would just take a lot of time. Maybe like get every elytra in the end or something with the ship. That could be cool. That actually would be cool. Is that possible? Just go up. Yes, I know that I just said that. I did just say that. I did say that just now. That is what I said. I said it would be easy. Yep. We need to do a sanitizer. Is velocity sanitized? To nether roof. Make everything easy, I guess. 10 times easier. That's the point. That's the problem. It's so easy. I might as well just. It's the same as going in the overworld. It's so easy. That's the problem. It's too easy. I don't want it to be easy. Ben, I am not doing this because it is easy. I am doing this because it is hard. Quote JFK, one of the presidents of the United States of America. God bless. I guess I don't know why I did that. I need to go to the bathroom. I'll be right back. I need to go to the bathroom again. Head looks so flat without these. Okay. So I had an epiphany while I was in the bathroom just now. I didn't wash my hands at all. These are completely dry, by the way. So my epiphany, it's not really that big of a deal. We have a check for the PID result. Start singing "Mommy, what is it, Caillou?" I will ban you from the stream if you tell me to do that again. Should I? No. No, we're not doing that. We're not doing that. We're not doing that, okay? I'm not doing that, okay? I'm not doing that. Caillou. Okay. Yes.
Okay, okay, we have the vector. This is the way we're going. The ship is going this way. This is the vector where the ship's going. The PID loop gives us a vector and how to intercept that velocity, right? Or sorry, this is the desired velocity. This is the velocity we want. This is our current velocity. The PID loop will give us some sort of vector to do that. Like likely it would be, hey, turn to the right, so you match that velocity, right? My right. But what if it somehow is in a positive feedback loop and it says to match that velocity, simply turn the complete opposite direction? That would be what, dude, I don't know. But okay, whatever. If it tells us to do this, then we can check that by looking at the dot product, right? So if we want to go this velocity and it's telling us to go this velocity, we could check the dot product between these two vectors, which this would be a 0 dot product, this would be a 1 dot product, and this would be a -1 dot product. If the dot, ow! That hurt. If the dot product is negative between the two vectors, the PID loop is likely in a I know I am. Anyway, okay. So if the PID loop gives us a vector that tells us to go, hold on. 1 second. Oh. I am on the Jumbotron. Here we are. I'm on the Jumbotron. Okay. So this is my explaining. This is my explaining phase, okay? Oh, God, my head is always so itchy. Fuck. Okay. If the PID loop vector is negative, right? If the vector is going in the opposite direction, or even like kind of the opposite direction, the dot product will return a negative value, right? In that case, we have computed that said vector is complete nonsense. What?
Only 240p quality.
Actually, why is it? I can count the pixels. Why is it so bad? Actually, why is it so bad? I know. Hold on. Where are my stream settings on? I have to move my phone out of the way. I think I might have set them slower. You enable? Whatever. I couldn't be bothered. It's fine. It's not a big of a deal. Whatever. Okay. Anyway, we check the dot product if it's an insane vector.
Your lip sync is show off.
I know. God, anyway. This fat ass keeps interrupting me. Sorry. I love you guys. Anyway. An insane vector, that's one way we can determine an insane vector. If it tries to accelerate us to a speed that is way beyond what we're trying to go, then that is also determined to be an insane vector. If a vector is insane, after a PID loop, if the PID loop returns an insane vector, then we cannot trust the PID loop. We must fall back to a non-PID method of control. Right? So that would be the degraded state of the SAS system. The degraded state would be where it can no longer trust its own PID loop. And I'm like itching my pancake chins. I'm fat as hell. The degraded state would be where there is no PID loop running. Why are my lips so blue? Hold on. Let me put on my lip. Lonqueer. Lip lonqueer. Your lip sync is so off. Dude, go fuck it. I responded to that like 3 times. I don't know why I keep responding to that. Baby. I know. He's like, it's off the side now. Do I have like a wipe? Yeah, I do. Right here. Just wipe off of that. This has become a makeup video now. I think that looks alright.
Wipe like how you. Shut up. Shut up. Okay, shut up. Okay, private. PID.
It's time to consider. What's it called? Abstraction. Does this function become unique to the PID loop? Question. Or is this also, what do you mean ew? Or is this also in accordance with the sanity check we do at the very beginning of the update process? It's time to think. Sanity check. Does the desired velocity have to be in line with the current velocity? No. Does the PID loop? Yes. We don't have an error velocity though. No, they're fundamentally different, but they share. Okay, the PID loop is like it. I think the PID loop is the same, except it's deeper. So, Mommy, what does it call you? I don't know. I know it's Birmingham. I can't do that high pitched voice anymore. Mommy. Wow, that's Homer. Okay, I'm sorry. I'm sorry. I'm sorry. Yes.
Hi. That's the best I can do with my high pitched voice. Dude, I used to be able to scream like a fire alarm. I miss those days. I don't miss those days. Okay. PID loop. Shut up! PID loop vector sanity check. Extends the standard check. Error vector. They're so short. This is how tall I am. Hold on, I'm going to show you how tall I am in reference to Matthew. There's a bunch of shit over here. Carefully navigating. Okay. Hey guys. Of course, Ben's screaming about man, faggot. Dude, I'm like balancing on something right now. In your underage, Oliver is hello. That's what I'm reading. Hold on, let me. Men, in your underwear. No, I'm not. I'm wearing shorts. Pull it up more! You actual pedophile. Do you mean to like have my shirt resting higher? Or are you telling me to pull my shirt up? I can't tell if you're being a pedophile or not. Here, let's see how that looks. I'll tuck my shirt in. Wow, nice voice crack. I used to do this a lot with this shirt, but then I stopped caring because it kept getting untucked because these shorts are so loose.
See, here we go. This is what it looks like when it's pulled up. Kind of looks, I don't know. It's different. I don't know if it's better. I don't know. I think both are good. I just kind of use this because it's easier. But also that other one looks good. That's my fashion advice. Talk and lock. We did it, guys. Emergency message center. Woman and anxiety. What the hell are you doing here? Of course. Never mind. I'm a good person and I would never say that. Good morning, chat. The fuck do you want? Heart. I'm a pedophile. Okay. Let's actually work on this. It will leave. Okay, so we need to take in two vectors. The error vector sanity check, right? We need the current vector, the error vector, and the desired vector. Yeah, can't get yourself canceled on YouTube. It wouldn't be the first time I've lost streaming rights. The Bunny channel is not allowed to stream. It's because me and Ben did a stream one time a long time ago. In person. And it was, apparently we're too young. Okay. Show us your other monitor. Hey guys. You're in my hand now. That's right. Yeah, wireless webcam. What, bro? Why did you do? This is what I see. This is how I see the world. This is how I see the programming lens. That's me right there. Do you see that? Handsome devil. This is what's on my other monitor. I got OBS right here. And I got helium over here. Hello. There's this guy right here. This handsome devil right here. See? Look. Extends. You know, I'm now realizing I forgot to go back to the monitor view. I'm so dumb. This is going to turn a Boolean. Is it stable? Is it stable? Is it stable? Is error vector sane? If not, is error vector sanity status? And we'll return a. Yeah, I was wondering register cam. What stream did we do? Was it the cooking stream? Yeah, it was when we were cooking mac and cheese, I think. Yeah, I was wondering if why are you screaming at me? God. Okay, we need to define a new enumeration. Error vector sanity status. Because some vectors that are insane we may be able to recover. Why am I 3 not 1? What'd I do? What the fuck you mean? What'd I do? Heart 100. Thanks for the engagement, guys. Did I tell you guys at the beginning of the stream I spent $8 to get this VS Code theme? This black theme in the background, the color of the text, that cost me $8. $8 for these icons too. I paid $8, but it's the best damn theme in VS Code. I don't even regret it. I'm number 1. God. Okay, we'll say sane. Sane is if a vector just is fine. We'll do recoverable. Why'd you spend $8 on a theme? Because it's the best that there is. It's the best. It's not just one theme. If I go to Control Shift P, And color. I got like all the Vera ones. I bought the Vera theme. All of these Vera ones I bought, so I can make it look like this. I really like carbon. It's probably my favorite. There's also graphene, which is just way too high. It's like that's like Sublime Text back in the peak days, back when it was really existing. God rest your soul, Adam. We miss Adam, the text editor, not the thing that lives over there. Okay, so sane, recoverable. You can code perfectly fine with that, I think. Marina, I am staring at this screen for hours at a time. Yesterday I was programming for 14 hours. The slight difference in the color of that pixel, the background, can change how I feel that day. This color, of everything I've ever used, this color is the perfect one. It is perfectly black. My eyes don't get strained, and I can see everything fine. This has been handcrafted by a team of geniuses to provide the optimum programming experience. You're welcome. You had to spend $8? No, I'm not just saying black. I'm not saying black. I'm saying this specific shade of black. This specific pigment. This specific hex value. This specific RGBA code. This specific one. I see now, I get it. There we go. Look at me doing it the C way. Man, I wish I could program this in C#. That would be nice. I actually don't dislike C#, but TypeScript's alright. JavaScript is for losers. Can you put a mini player of slime? No worries, I got you. Slime video YouTube. You're such a loser, by the way. You're such a loser. Okay. Is this watch in HD? You should understand when you're involved in do-it-yourself. All videos. Is this? Am I allowed to use this? Slime video ASMR. Copyright free. 1 hour slime ASMR. Is it copyright free? Come on, just tell me. Is it copyright free? No copyright. Satisfying. No, I don't want that. I want 1 hour of oddly relaxing slime ASMR. Tell me, is this copyright free?
Why is no one? Come on. Okay, it's all the same person. They're not saying it's copyright free. Very satisfying, relaxing, kinetic sand ASMR. 8 hours of solidly satisfying videos. The comic music. I'm not contacting you for a fucking slime video. Dude, I actually can't find a single one without copyright. How does one copyright slime? The content of them recording and doing it is copyrighted. The editing and everything they did to it all fall under the copyright of the video. Dumbass. No copyright. Okay, well that's 3 minutes long, so probably not. Here, it's either this or Subway Surfers. I better pull up Subway Surfers if I can't find this shit. "12 hours of satisfying AI ASMR glass cutting." No, that's AI. I could do AI though. I think AI doesn't fall under copyright law. Actually, I think it's like a gray area right now. 9-in-1 video, best of collection slime. Pleasant viewing. No, this is not free. Come on. I just need someone to write in the description. This video is free of copyright. Use it however you want. That would be great. 24 hours of relaxing slime videos. Is it copyright free? Go fuck yourself. Why are none of them copyright free? Tung Tung's a horse slime. You see, I want to look at that, but I can't because it's not copyright free. Patrick! Oh my god! What have they done to you? I'm so sorry. Contact. The best satisfying. Well, is this the best copyright free? I'm sorry, Marina. I can't. They're all apt. Do you have? What the hell does that mean? I can't do it because, well, I'm afraid it's just all under copyright law. I don't want to violate the law. I couldn't find a single one that wasn't copyrighted. I'm not contacting them right now to get the video. So it's probably really sad for you. Why don't you see what? It's not copyrightable if you just do it yourself, you know? At this point, do you have? Are you asking me to pull out a thing of slime and just like do it for you? That's kind of fucking sad, you loser. I'm real sad. You could just, okay, just get another window of slime and put it there. This isn't rocket science. I said at this point, do AI. No, okay. Still, AI is a legal gray area. Like, as far as I understand, the Supreme Court hasn't decided if it falls under copyright law or not, and who exactly it would belong to. I think if I took the AI video, the editing between AI clips would put it under copyright law of the author. So, I don't want to do that. I'm on phone. I don't know what to tell you. I'm not violating the copyright law for you. Would you steal a car, Marina? Exactly. Yes. Maybe lose my focus just a bit. Okay, let me think. Good luck. Under what situation would a velocity vector be insane? Unrecoverable. I don't know. Maybe that will be something later. If the RCS sends like a don't turn at this angle warning. You take a while to think. I want to see you do this, Ben. I want to see you make a flight computer with stringent safety guidelines by aerospace corporations. I want you to do it. I want you to do it. I want you to defensively program a flight computer. Shh, I'm thinking. Talking to Marie. God. What are you thinking about? What, Shut up. Games are copyright free? No. No. Do I create a class just for this? No, game soundtracks are also not copyright free. The entire thing, music, the game, none of it's copyright free. Unless the author of the craft or the art or whatever specifically states that they revoke their copyright of it. Playing a game
A video of someone playing a game falls under the copyright of the person making the video. The game itself falls under the copyright of the developers of the game. So the game and usually the soundtrack, all those are under the copyright of the people who made them. If you're playing a game, that falls under the copyright. I thought game soundtracks were fine to use in videos, only if you have copyright permission from the composer or whoever is responsible for it. But if you were like playing a game, the copyright soundtrack, the soundtrack, like you could get in trouble. Like theoretically, you could get in trouble for using the soundtrack of the game in your video. It's just that's very unlikely to happen. No one's going to copyright claim you for playing a game and using the music in the game for the video. Playing a game itself, like that is in an extent like transformative. Like if you're playing a game, you're transforming the game by playing it. Like you're playing it. You playing it is an act of you transforming it because games are necessarily interactive, but music isn't interactive, so you can't transform it. At least unless you're like reviewing the music, that would be transformative. It might fall under fair use. But playing a game would fall under fair use for that reason, I believe. Actually, let me look it up. No, it does not. Actually, I was wrong. Publicly broadcast streaming or uploading that gameplay does not qualify for under fair use. Instead, it falls into a legal gray area where publishers largely rely on tolerance and licensing. Interesting. So I was wrong. It's not. It does not qualify under fair use. They just allow you to do it. Okay. Didn't I use Symbiotic music in your vid? I think because I bought the OST. Hold on. Hold on. I can look it up. Symbiotic OST. Yeah, I think because the gameplay was Subnautica, and I bought the Subnautica OST, that I have permission to do it. Though it could also be possible that it could also be possible that I infringed on copyright. I guess they can sue me. Like the music you're hearing in the background, every single video I use with this music gets copyrighted. I just don't care because I like it. The Doctor Who soundtrack, by the way. So we need to sanitize it. Our nature documentary is copyrighted. If it's just a live stream of nature, okay. So a photograph is under copyright law because a photograph is like the editing that it takes to make that, the positioning of the camera. It's considered minimally creative, so that falls under copyright law. A video, for the same reason, and so. A nature documentary with video and like some guy in the background explaining what's going on and editing between clips, that would very likely, I think, fall under copyright law. I can look it up. I'm like 99% sure. Yes, nature documentaries are fully protected under copyright laws. Put a nature live stream in the corner. I cannot do that because that would violate copyright law. Unless I had permission from the person that made it.
Isn't that how you spell sanitize? It falls. Are you asking why I can't do it, or why it falls under copyright law? It falls under copyright law for the same reason a photograph does. You have to move the camera to a specific place. You have to use a specific lens and do some cool stuff with the camera to get just the right video or live stream or photo. And that, under United States law, is considered minimally creative, meaning automatically that work is under your copyright law. It is your copyright laws, and I cannot infringe. I cannot use that video without explicit permission from the person who made it, or whoever is copyright is like the copyright owner of it. Dude, it is so cold in here. I'm gonna turn on, or hot in here. I'm gonna turn on the AC. Put my fat gnat speed paint in the corner. Where is that? Can you see that? Do you hereby give me copyright permission? We're in writing to do that. Oh my god. Ben, are you in Discord? Ask them freaking code. Who is that? Can I say some mommy, but he's a kite. But muted. Okay, where is it? Okay, let me see. That's my music! Oh no, you changed it at the end. Okay. Is that Alan Walker? Okay, well, I'm not. I want some music though, but I think I probably could get away with it. Is this it? Watch it be some random ass bullshit. Okay. Muted. Okay, I'm fine. That was my music, so I'm not gonna get copyright claims. Alright. Here we go. Beautiful. There we go. Just amazing. I know. I think that's every possible path. So if it's insane, it's recoverable. And we reach here. Okay. Oh, where'd it go? It's gone. Move. Gate me. What does that mean?
Okay, so we have the sanity sort of implemented. This, we only really need the get function for this because to sanitize it, or is it the sanitize velocity vector? This doesn't matter if it's an error vector or not. It doesn't really care because it doesn't change speed. The get velocity, error velocity sanity only does a dot check. The dot check fails, there's nothing we can really do at that point. I mean, we could technically nudge it back in, but that would end up causing more confusion in the PID loop. It's not really worth it at that point. The PID loop is inaccurate. The PID loop has failed. We need to do something else. So if we're getting recoverable here, we need to set that as like a warning in the log. Like, hey, it's recoverable, we can fix it, but whatever you're doing, this shouldn't be happening. During operation, 100% of the time, this should be returning sane. We should always be getting sane. The velocity vector should always be sane. Whatever isn't sane, then something is wrong. What Stardew Valley video? Food me, food me, food, 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 food. I don't think we said this as a failure. It's the job of the SAS system to recover from something like this. So I think we just do this, but we send a signal to the crisis management system. Unexpected or impossible input. Impossible input. But we need to figure out a way to stabilize it. Stop ignoring me. I literally didn't ignore you. I said, what Stardew Valley video? And you said nothing. You completely ignored me. I literally asked what video, and you didn't say shit. Stupid idiot. Don't ever try to second guess me. Do you know who I am?
my Stardew Valley the name of the game? Or is it literally called... Is it called Stardew Valley? Or is it like a video you made? No, it's called... Yeah, okay. So what are you... What video? Why didn't Discord get rid of this? Oh, jump to present. There we go. Gameplay, no music. Okay. Yo, ma. Yo, God. I'll be right back. I'm back. You know, I'm not realizing this video might get my stream taken down, so I'm moving that out of the way. Welcome. Hold position. Hold position is a starter protocol. It should set the status to hold position. That's not a bad idea. Holy shit, I'm a genius. Oh my god, I'm so smart. Genius. Genius. I'm a genius. So, here's the question. Here's the question for you. What do you think? Should it share the system state with everything else? Or should it have its own state specifically for the SAS system? Or should it have both? I think... Okay, because the more states I add, the higher the complexity. Right? I add both. Okay, but here's the thing. If I add more states, it's more complex. This is a mission critical system. And complexity is sort of what I'm trying to fight. If I add both, it's really easy for the crisis management system to determine in a crisis what is going on with it. But either way, I would have to do a check. But each system has the online-offline failure state. And all this would determine is what it's doing rather than its activity status. It says there's 2 concurrent viewers. What do you think, other person watching this? What do you think? What do you think? I'm not talking to you, Marina. I'm talking to the other person that's here. Ben OMGG. Is that your name? Ben, is it? What do you think of this predicament? What should I do? This is interactivity. I'm interacting with my chat. I said what I think. Yeah, good thing I'm not fucking talking to you. God, stop. I've said like 3 times I'm not talking to you. I'm talking to the other person. The other person, okay? I'm talking to Ben OMG, if that's his real name. Are you at my door? I guess Ben just hates me. Okay. So... Are you at my door? Is that you, Cub? Okay, give me a second.
I said what I think. No one likes me. I'm a loser. No one loves me. I am fat as well. Okay, I'm back. I'm back, guys. I'm back. No worries, guys. No worries. No worries. I'm back. No worries. No need to worry, guys. I'm back. Don't worry, guys. I'm back. Don't worry. ASMR. No. 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 Hold position? Hold position? No. No. Hold position is the responsibility of a navigation system. We are not a navigation system. This is an aviation system. It should not have an emergency protocol to hold position. It should have an emergency protocol to... What should the protocol be? If the PID loop is giving faulty information, it needs to go into degraded mode. If the velocity it's getting is wrong, it needs to give its own velocity, and that should be... We need a way of keeping it stable. So we could continue with the velocity we have, but that would inevitably result in a collision. This SAS isn't responsible for avoiding collisions, so it wouldn't be able to do anything. It could pass its own vectors into it, but that would be antithetical to the point of the SAS. That would be the responsibility of the TDAS. Again, it depends on the failure state. It depends on why it's not working. Okay, so we're currently going down the path that we're currently going down. We are receiving faulty velocity information from the navigation controller. The SAS system is attempting to remain stable even though it is receiving faulty navigation information. The faulty navigation information it's receiving is from the terrain destruction and avoidance system. The terrain destruction and avoidance system is responsible for avoiding terrain by not colliding into it. And it is also responsible for other things as well. But it is not responsible for a vector being insane. So if we get a vector that's trying to get us to go too fast from the TDAS system, we have to verify, is the TDAS sending us an emergency command? The TDAS system is sending us a command flagged with an emergency. That means the TDAS is performing an invasive maneuver, like avoiding a collision or avoiding a fire zone. So we don't really have to care. We can just go ahead and override the PID loops and go straight to the velocity of the RCS. Effectively pass it through to the RCS system, because the TDAS has flagged it as an emergency maneuver. There is no circumstance where it cannot accept an emergency maneuver. It does leave a failure point though. What if the failure flag stays on? So the failure flag has to be physically attached to the vector and not set in the state of the SAS. Right, and then every vector must indicate if it's an emergency vector or not from the TDAS system above it. But what if TDAS stops sending us anything, or the information it sends us is gibberish? Well, okay, well, what is connected to... Okay, so TDAS... Okay, but TDAS calls us. So if TDAS fails, then we fail automatically. Oh, and that's the problem. That goes up the stack. The top one to fail disconnects everything below it, which is the exact opposite of what we're trying to do. So we need to decouple. To that, we need to decouple the RCS from it, and then we need to forward that through the FMS as a state flag. But what happens if... Okay, so here's the situation we're in. The TDAS system has suddenly stopped giving us information, or the information it's giving us is unreliable. It's giving us nonsense or impossible, insane vectors. Our responsibility as the SAS is to maintain stability of the craft. The TDAT, the navigation system, is responsible for keeping it level. So that brings another question. What is the SAS system trying to do? Is it trying to maintain velocity or position? The goal of the SAS is to keep the craft level. It is to keep it in position and level. So shouldn't it receive a position? But if it received a position, then it would be doing the job of navigation. But it's an aviation controller. So what can it do? Okay, well, it may not know the position of the craft, and it may not know... Right, okay. So the goal of it should be to stop accelerating. The goal of it should be to just thrust in the opposite direction of its velocity. So the TDAS stops giving us reliable information. The thrust of the SAS goes in the opposite direction of the velocity times a fixed multiplier. No, that's wrong. No, okay. So, okay. Here's the plan. Full picture. The SAS system is running. We're flying, we're in flight, we're navigating. All of a sudden, the terrain and destruction avoidance system fails. We no longer know how to stay level. We no longer know where we're going. We're receiving nonsense or gibberish or just nothing from that controller. The SAS system doesn't know where it is. All it knows is its current velocity and its current rotation. The SAS system changes its strategy to hold position by going in the opposite direction of its velocity to slow down, and to go to a fixed quaternion, which is its stable rotation, and that should be a fixed value in the config file of what rotation it should try to achieve. Or it could be dynamically calculated, because the RCS system, if it has a thruster failure, that changes the amount of allowed angles that we have. So we don't want to edit a config file. What do you mean, yes? Okay, and then after that, it goes. So so all a TDAS failure would do would change the directive of the SAS, or change the SAS system probably wouldn't even notice, except for the the SAS would flag that it's receiving nonsense data, and then it would just tell itself to just stop moving. The SAS system sends the data, whether that be after a failure or just during normal operation, just when nothing goes wrong or when something goes wrong. It sends the data to PID loops, magic stabilizer things that sort of slow it down and make everything smooth and nice, to stabilize it. Should the PID loops give nonsense information or somehow cause a positive feedback loop, we stop using the PID loops. The SAS system goes into degraded mode. It instead multiplies the air velocity by a set specific emergency multiplier in the config file, which makes it less stable, but still stable-ish. It will be able to maintain position, just not as well. It'll be able to maintain orientation, just not as well. I think that's the plan. So the SAS will have two modes: normal mode, degraded mode. Then there's offline mode, online mode, and failure mode. And you're right. So how do we initiate a hold position directive? Well, we need to determine, is the information we're getting from the TDAS gibberish? How do we know if the information we're getting from the TDAS is gibberish? If we are receiving a vector that is too fast and the emergency flag is not set, that vector is gibberish. We then must hold position, tell the crisis management system that we received gibberish, and the crisis management system will figure out what to do from there. It could have been a one-time fluke, maybe a bug in a chunk load accidentally made us go too fast or some shit. In that case, it's possible that it wasn't actually a malfunction. The crisis management system would likely, after a few tests, deduce that, and then just tell the SAS it was just a one-time thing, go back to work. So what do I need to do right now? Right now, let's do the PID loop failure mode. The PID loops fail, we go into degraded mode. Let's do that. Let's worry about hold position stuff later. Let's just comment this out for now. For now, let's just worry about the PID loops. Sending gibberish. Yes, you see, this is a good idea. We both agree. Okay, we have the PID loop gibberish check. We have a check to see if the PID loops are just flat out, like, just dead. And that's on the power on self-test. It technically could be possible for a PID loop to fail mid-flight, but no, it really wouldn't, because there is no error state for it. So the PID loop is pretty... Other thing we're not concerned about the PID loop class itself failing. We're concerned that the PID loop is giving us nonsense information. It's telling you, like, hey, you're trying to go that direction? Here, go this complete opposite direction. If it's giving us nonsense information, that's what we're worried about right now. Okay. Okay, so... Oh, where is it? Stabilize velocity. So this is where we stabilize velocity. We get the velocity error. And we have the... Okay, so we're not caring about the velocity error. We got the PID result. One heads up, we've detected audio in your stream belongs to someone else. Oh. What is this? May temporarily be blocked. Am I playing any audio? It's the music in the background. I'm gonna have to mute Song of Freedom. RIP. That sucks. That's annoying. I think I have a pizza tower sound over here somewhere. You know, if I want to avoid a copyright strike, I know just the sound to play. Alright, they can't copyright strike me for this. That's way too loud. God damn. I love how it's just one of the best soundtracks ever made. Fucking loser. Fucking loser. Dude, me swallowing is so disgusting. Oh! Dun, 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 dun. It's probably horribly out of sync. Okay! We need to check, is the PID result complete gibberish? We have the function already, so... let's do the determination, the mathematical approximation. Let that sink in. Okay, Mr. Musk. PID sanity status. That is going to be Victor. It's going to be equivalent to this. And I forgot, we need to, for these two, we need to pass this in. It's not implicit in my setup. And this is going to be, of course, the stability augmentation system. Get error velocity sanity. Get error velocity. Okay, that's correct. That is correct. It's gonna be PID result. So basically, we're checking, is the PID result giving us complete gibberish? Okay, now we need the vector it's coming from. The vector it's coming from is current velocity, and the vector it's going to is desired velocity. Okay. So if it's gibberish, if PID sanity status, if this is PID sanity status equals vector sanity status, that insane. If it equals insane, then the actual, like, the PID loop is just giving us bullshit. We need to cut it off. So we need to activate the emergency protocol corresponding to that, and then we need to notify the crisis management system of the PID failure. The crisis management system will likely wait a few seconds and then try to, well, actually, would a PID loop failure indicate an issue that the crisis management system needs to be aware about? I think it would be a good idea to report it to the crisis management system, but the crisis management system wouldn't really have the authority to handle that. That would be, yeah, PID failure isn't the that would be the responsibility of the loop itself would be faulty. So that would be the responsibility of this of the stability augmentation system. So I think we just do it, we make it a self-test, right? Every time after the failure of the PID loop, we run the PID loop still. We just don't actually use that information. If it's insane all the times, then we still don't use it. But if it ever suddenly becomes sane, like if, say, there was just some issue and it repaired itself, then we can go back to the PID loop. I guess it overall just depends. Okay, hold on. Whoa, we gotta think about this, because now I'm imagining a scenario where the PID loop accidentally is pointing in the right direction. The PID loop, to get a velocity to a desired velocity, it must always be roughly... it must always be dotted with the desired velocity above 0. That is a fact. If it wants to achieve its desired velocity, it can never go the opposite direction. But potentially, there could be some wiggle room. But usually it would be between the current velocity and the desired velocity. The PID loop would be giving you some result in the middle, right? To get the velocity you want. But it's also technically possible that it would overshoot it slightly, but then the vector, in that case, would be considered gibberish,
when it wouldn't be gibberish. I think we're just gonna do the easiest solution. The best solution to problem is usually the easiest one. We're just gonna determine if it's dotted. If the PID loop is okay, how about we do this? We have a sample size. Every 10 PID loops, every 10 loops, we check every loop we check, is the PID loop working? Is it working? Has it fixed itself? If after 10 tries, it still has even one that is wrong. If it still has even one of those is faulty, we will still continue to use the backup system. We will not use the PID loop until all 10 tests of it succeed. So 10 tests per second, or not 10 tests per second, it would be 10 tests per half second because it runs at 20 ticks. 20 ticks per second. So, okay. Back up. What are we actually doing? Every tick we check, is the PID loop working? If the PID loop is not working, every tick we check, is the PID loop working? And we store that inside of a list, right? After 10 tries, we have a list of 10 different results, 10 different successes or failures. If in that list there is even one failure, we will continue to not use the PID loop. If it ever so happens that 10 consecutive PID loops work in a row, then we will switch back to the active system and use the PID loops. If there's a failure, it'll probably make itself pretty apparent immediately after, and we'll switch back to degraded mode. So that's the plan. But right now we need to make the switch over. So emergency function, switch to manual. Switch to multiplier. So now I'm just going to switch loops to manual. And then we'll have another function called switch loops to PID. Smart words? I know, right? This is 99% of programming for me. Literally, it's not just that I have this camera here. Like what I just did where I fully said all that shit to myself, I actually do that. Like when programming, I just stare at my monitor and just talk the entire thing. Another thing. We are assuming the loops are the entire program, this entire flight computer. One of the philosophies, everything is guilty until proven innocent. Everything is broken until proven that it works. If we get one PID failure, just one PID failure, we go into emergency mode. It takes 10 consecutive successes to exit PID mode. So it is 10 times easier for the system to go into the failure state, which is exactly what we want. If we want a failure, we want to catch it literally the second it happens. Or in this case, it would be in a 20th of a second. And a 20th of a second will catch a failure. And we need to throw that error up to the crisis management. Okay, so we talk, okay. Imagine you are the computer. You are this marvelous machine, capable of computing things billions, if not trillions of times per second. And you are inside of its head, inside of this script, this program, if you will. You are the stability augmentation system. Your job is to keep the craft stable, even when other systems fail. It is your only priority is to stop it from flipping over, to stop it from spinning out of control, and other adjacent and related stuff as well as that. Now that you're inside of this mindset, now that your brain is in the computer, imagine you have these two loops called PID loops. What do these do? These are magic boxes. You feed in a piece of information and it outputs a smoother piece of information. They can make everything so much smoother and stable, which is exactly what you want. But sometimes they can fail. Sometimes they can give you nonsense back. You're the computer. How do you prepare? Okay, let's imagine. You run the PID loop, and you see that it's giving you gibberish, complete nonsense. You, in an act of desperation, activate your emergency mode, the PID loop. You stop using it, and now you're just using a fixed multiplier. It's a lot less stable, or a lot less stable in the sense that the craft itself is less stable. But the computer, it's much easier to do, and it's much more reliable. This is your degraded mode. Let's imagine that the PID loop happens. You enter the PID, it fails, and you go into the degraded mode. You then broadcast a cry for help up to the Lord above you, the crisis management system, whose sole priority is to deal with souls like yours who have failed or have otherwise been captured by the forces of failure. You tell the crisis management computer, please, what do I do? My PID loop has failed and I don't know what to do. The crisis management computer says, I understand. I hear you. Let me go ahead and tell this error. Let me go ahead and print this error to the programmer so the programmer can see that his PID loop failed catastrophically. And you son, you already know what to do. You're already in degraded mode. You're already doing what's right. Just keep going. You can do it. The SAS system says, thank you, crisis management system. Thank you so much for your help. The stability augmentation system then continues in its degraded limping mode, continuing because it knows that it must. Every single tick it can. It checks the loop. Are you working now? Are you working now? Have you fixed yourself? But it keeps getting staggered results. Sometimes it works. Sometimes it doesn't. The SAS keeps tab. If you work 10 times in the loop, if you work 10 times in a row, it told the loop, that I will let you be in charge again. The PID loop, with this knowledge, then decides it's time to work again. And then 10 times in a row, it works perfectly, full success, no errors. The SAS system is very, very impressed, and it puts the PID loop back in control and asserts itself as repaired. The SAS system has successfully overcome a PID failure. It has lived to fight another day. So just like imagine that when you're thinking of what I'm programming. That can help you. That is not the first time I've done that. I've done that multiple times. Writing a fanfic. No, Marina, I was pretending to be the computer. I have to be one with the computer to understand it, okay? You don't understand. Okay. So, we have to tell, this is, switch to manual. Okay, so to switch to manual, we have to actually define what does that mean. So we have to do SIS, backup, manual, translation, multiplier. This is going to be a number, and SAS, manual, we'll do rotation, multiplier. That's going to be a number. So if the loops fail, this is the degraded mode. Sorry, were you talking? Oh, what's talking? I was telling a story. A story. Okay, that was a story of beauty and amazingness and very niceness, and it was great and stuff. Okay. Maybe you could have listened, you know? Maybe you would have learned a thing or two. Dumbass. Yeah. Okay. And before we do that, we have to actually go to here, stabilize velocity. We have PID. We want to just completely skip this. So, but this would make it another layer. delicious sound. Sorry. Velocity PID loop. For now, I'll just return the PID result. So we have to determine what mode are we in. So we do if, what should we do? If we're in degraded mode, we want to use the multipliers. So if this dot state equals state, or sorry, system state dot active, then we're just using the PID loop. So we'll do return velocity PID update. All right, so that'll just do the stuff. Beautiful. That was a beautiful sound. I loved that. Velocity error, current velocity, and desired velocity. And we also need to set this. Like, always forget to set this at the beginning of a function. I'm so used to being implicit, but I've been trying to do everything explicitly for this script because, again, it's so important that it doesn't fail. Or this computer, I should say. Else if this dot state equals system
ASMR.
equals system state degraded. Return this velocity and update. It's the magnitude of the vector. That's it. We multiply. God, I'm a genius. We multiply the velocity error times the multiplier, the fixed multiplier. But the magnitude of it. That means the closer it is, the closer it gets, the lower the velocity it needs. I'm a genius. But wait, Oliver. Yes. But Oliver, don't you say whenever you have the error velocity, by definition the magnitude is already in the vector? And I tell you, yes, you're right. This whole realization I just had was for nothing because that's already what I was doing. I was thinking I could use a logarithmic curve, but I don't have to anymore. Because it does it itself. It's the beauty of the world.
I think this is okay. Can you step the fuck away? I'm all the way over here. I'm really far away from you, bro. Ben, I think your stream is behind, loser. Velocity error is a vector 3. It's gonna be pretty simple. We're just gonna return velocity error times this dot get, or sorry, this dot config dot sas manual translate manual translation multiplier. I forgot we have to do dot multiply because unlike Lua, we don't have meta methods, so we can't do multiply, which is super annoying. I think it's sort of impossible. Okay, so, no. So we always use it unless, so, okay. Yeah. So we're always going to be using that unless we're in degraded. So we only do this if we're in degraded. So we do if state equals degraded. Then we do the manual update. Else, in general, if we're anything else, we try to do... No. Okay, well, the issue with that is, what if we have a failure and we go into emergency mode? We go into emergency mode. That overrides the degraded state. So no, we need to do the opposite. We need, yeah, like I said, we need to be guilty until proven innocent. So the system is going to be assuming it's in degraded mode. If it's not in active mode, it's going to be doing the backup unless it's in active mode. So are you guys glad you're learning so much from me? So much data is being put in your head. So much things that you didn't know before. You are now learning. There's so much that you are seeing. So much beauty that you are digesting from me. I'm happy to help. I'm listening to myself right now. Yes, I'm so glad. Why? I'm so glad I'm learning. Exactly, Marina. You're going to learn everything. By the end of this stream, you're going to know everything about quaternions. You're going to know everything about vectors. You're going to know everything about everything in three-dimensional space. The dot product is going to be ingrained into your head, okay? You're never going to forget the dot product. I love the dot. The dot product is so nice. Everyone loves the dot product. Okay. Manual update. Yeah, we already did that. Yeah, I'm leaving. This guy hates fun. He hates fun. He hates learning. He hates knowing things. Right? That's why he's so dumb. It's because he hates knowing things. It's because he's dumb. That's why. It's because he's stupid. That's why. Oh no, it's because he has to go to the fat doctor. Never mind. It's not funny. I'm sorry. I'm sorry. No, I have a crucial appointment. That's what I said. You're going to the fat doctor. Ben, I think your stream is way more behind than what it actually is. Nah, it's pretty not. What does that mean? What? Alright. I think I'm gonna end the stream. I know, it's so sad. It's so sad. The reason being, you know... Actually, I don't know why. I don't want to stream anymore, is why. Is the reason why. So that's... It's terrifically horrible and like evil of me to do. I'm sorry for betraying you, but you know it has to be done. It has to be done. There's nothing. I'm sorry. There's nothing I can do. It's out of my hands. I can't control it. So I appreciate you tuning in to this Talking Lock production film. This Talking Lock production film, this live one that you saw. This one that you saw live. This Talking Lock production live film. This live motion picture, if you will. This live motion picture. This live motion picture is now over. Goodbye.